These are the frequently asked questions for pre-calculus, and this would be for section 8.1, day 2. And they both come from this group of problems. In exercises 11 through 30, find an equation in standard form for the parabola that satisfies the given conditions. So we start with a sketch. Wouldn't necessarily have to have a Cartesian coordinate plane, but very good place to go. The focus is at 3, 4. And we know the directrix is y equals 1. So y equals 1 is going to be a horizontal line right there. Now what that does is it tells me where this is going to go, up, down, right, or left, because I know that the vertex has to wrap around the focus, and the directrix is the line saying, don't go this way, go in the opposite direction. So halfway between where y equals 1 and the focus is 3, 4 is where our vertex is going to be. So the coordinates at that point, pretty obviously it's going to have a 3 in it. So we start thinking about our vertex. And then it has to be halfway between this, which is 1, and this, which is 4. So halfway between, add them up, divide by 2. 4 plus 1 divided by 2, 5 halves. And for graphing purposes, we could probably use 2.5, but in the equation, we maybe want to stick with that incredibly accurate fraction right there. So there's our vertex. Now, the next thing that we have to have if we're going to write the equation, and at this point, we do know this is opening up, so it will be x minus h squared equals 4p times the quantity y minus k. The next thing that we need to have is p, and p is the distance from, still don't like that k, the distance from the vertex to the focus. That's our focal length. So now that we know that our vertex is going to be right here at 3, 2.5, we need to figure how far it is from 2.5 to 4. And that's going to be 1.5. So our p-value here is 1.5, and it's directed distance, so I think, do I need to put a negative in front of that? The answer is no, because this is definitely going to be an up-opening parabola. So now we go to work. X minus h, reminder that h and k are the vertex, so x minus 3 squared equals 4 times, our p-value was 1.5 or 3 halves as a fraction. And then y minus our k value, which is 5 halves. And now we'll just clean it up a little bit. X minus 3, the quantity squared, equals 4 times 3 halves will give us 6 times the quantity y minus 5 halves. And that looks as an equation for an up-opening parabola should look. Then also number 24. And number 24 is giving us the same type of information. We have a focus at 2, -3. And we have a directrix at x equals 5. And that is a vertical line. So now we can see the directrix is going to say, don't go this way, go the other way. So this is going to be a left opening parabola. And that left opening tells us we're going to have to use y minus k squared equals 4p times x minus h. So we need the vertex. And again, the vertex, I don't like where I put that f there because we need to go halfway between that. So let me get my f over here. And that's at that 2, -3. And this line is 5. So if this is at 2, -3, and this is at 5 for x, we have to figure out, well, how far is it from 2 to 5, and we have to split that. So 5 minus 2 is 3, and 3 divided by 2 would give us 1.5. So it's 1.5 units from the focus to p. And that will put it right there. So now we need to figure out the coordinates of that point, and that is going to be 1, 2, 3.5, -3. And just like the last one, we want to work with fractions here, so an improper fraction for this vertex would be 7/2, -3. So there's our vertex. Next thing to find is the distance from the focus to the vertex, because we need that information for our p-value in our equation. And we just said this is going to be at 7/2 or 3.5, and this was at 2. So 3.5 minus 2 is 1.5, which of course is 3/2. So our p-value is going to be 3/2. So quite a few fractions to deal with in this one, but let's put them in. This is h and this is k. So we'll have y plus 3, the quantity squared, equals 4 times our p-value of 3/2, and then x minus h, which is our 7/2. And then we'll clean it up a little bit by taking 4 times 3/2, and 4 times 3/2 will give us 6. And if we stop here, we missed something. That something is, because this is going left and our p-value is directed distance, that should be a -3/2. So that will be a -6. And usually when I do these problems, that's the last thing that I go back and take care of, is whether or not I should be positive or negative. And that's the habit you want to get into, is just always doing them the same way. So if you want to stop right here and figure out whether or not it's positive or negative, that's another good spot to do it. You know, at that point you could say, wait a minute, from vertex to focus, that's going to be going to the left 1.5, so that needs to be a -3/2, and go that way. But like I said, just come up with a plan on a comfortable way for you to always go through those same steps again, because when you have that repetition, then you won't forget those.